Hello there, children. Today we are going to keep working with right triangle trig. Educational experience is brought to you by your rad teacher of right triangles, this guy. Alright, so yesterday we talked about, or before we talked about, all the different trig functions and things like that. Now we're actually going to apply them. So what we could do is we could be asked to solve the following. Find the exact value of the 6 trig functions given a triangle. So we have our 6 trig functions. I put the definitions for sine, cosine, and tangent down, but you don't have to know those and memorize those. So, given this triangle, and they give you the position of theta. If you don't know the position of theta, you really can't find all 6 trig values because depending on the position of theta, your trig values are going to change. It's very important for us. So, we look here. So sine is opposite over hypotenuse. Opposite being 21, hypotenuse being 29. Don't need to give me decimal here, just write it like that. Cosine is adjacent over hypotenuse. That is 20 over 29. Now it all depends again on the position of theta. If theta were different, these trig values would be different. And tangent, as we know, is sine over cosine, but rather than create myself a complex fraction, I'm going to use the other definition of opposite over adjacent, which means 21 over 20. Now I have to find the other trig values, cosecant, secant, cotangent, not the big 3 as we call it. Well, luckily for us, I remember that cosecant, secant, and cotangent are the reciprocal of my big 3. So I just take the reciprocal of all of these wonderful ones on the left. Remember, cosecant matches up with sine, secant matches up with cosine, and tangent matches up with cotangent. There you go. You have found all 6 trig functions. No need to give me the decimal there. So we can proceed onward. Now, the problems could get more difficult as well. So what they could ask you is say, hey, look, given that tangent of theta equals 1/2, find the remaining 5 trig functions. We need to create ourselves a right triangle. Why a right triangle? Well, besides the fact that this is a right triangle trig, that's the only thing we really know how to deal with. I know the definition for tangent if it's a right triangle. So I'm going to create myself a good old-fashioned right triangle here. Put theta wherever you want. I put it down in the corner so it's easier, but you can put it up top there if you want. It doesn't matter. Now, the definition for tangent you have to know is opposite over adjacent. So the opposite here is 1. The adjacent here is 2. Now, unfortunately, I have to find the other side of my triangle. Now, how exactly am I going to do that? So, now that I have a right triangle, find your missing side. How do I do that given a right triangle? How do I find missing sides? Hint, a formula that involves A, B, and C. A, B, C, it's easy as 1, 2. This isn't going to be 3, unfortunately. We're going to use the good old-fashioned Pythagorean theorem. For those that forget, Pythagoras would be really upset. I mean, it doesn't matter right now. He's dead. But he'd be upset if he were alive. Pythagorean theorem. And luckily here, I know the 2 sides that I'm looking for, c squared. The good old-fashioned hypotenuse. So when I fill all this information out, I get 1 plus 4 equals c squared. 5 equals c squared. I take the square root. Now, you usually get plus or minus, but because we're dealing with a triangle here, I don't need a plus or minus because it's a length. It cannot be negative. So I found my hypotenuse, and then I can go ahead and find my other 6 trig functions. Okay, so given my triangle there, I need to find all 6 trig functions. Now, sine is opposite over hypotenuse. That's swell. Except, look what's in the denominator. Oh no, a square root. Womp womp. That's not so swell. I've got to rationalize that. And I'll do that in a second once I fill all these out. Cosine is adjacent over hypotenuse. Oh man. Again, slight bit of an issue. Tangent, opposite over adjacent. How did I know tangent so quickly? If you remember, they literally gave me tangent. So if they're asking you to find all 6 trig functions, they're telling you one of them. And luckily for us, once they tell me tangent, I automatically should know what cotangent is, because it's the reciprocal of my tangent function. Now secant over here is the reciprocal of cosine. Notice how I write these out as well. I write the big three on the left, sine, cosine, tangent, and then I write the other three over here in this order because their reciprocal is right next to it. It makes it much more visually appealing to go ahead and do. That's root 5 over 1, or just root 5. Now going back to these other two little creatures over here, this isn't quite correct because it's got square roots in the denominator. So I've got to rationalize it by multiplying the top and bottom by root 5. Because remember, if I've got to have square roots, I really don't want them in the denominator of my fractions if I can avoid it. And I can avoid it here. Oh, happy days are here again. So I have root 5 over 5, because root 5 times root 5 is root 25, and the square root of 25 is 5. Here I have 2 root 5 over 5. Now I know what you're thinking. I can cancel out those 5s. No, you can't. Think about it this way. This 5 is in the house. That 5's out of the house. They can't play with each other. Your mom's not going to let you throw a ball from someone outside through your kitchen window in your house. That's just dumb. So if they're in the house, they can play together. If they're inside and outside, not allowed to cancel. So don't forget that. Now, I know that might seem quite simple, but it's something we have to remember. Now, what we're going to do in the future here is I'll be able to figure out this exact theta angle using, remember, inverse trig, because inverse is for angles. So that's something we have to be aware of. But right now, you are more than capable to do the next assignment before we get on to wonderful and glorious word problems. So go henceforth and do. Oh, happy days are here again. Commence.